Hello students, today we're going to continue with the laws of indices. The next law we're going to discuss is product to a power. So students, let's say we have two terms a and b. They get multiplied and they have the same exponent, suppose n. So instead of writing the separate exponents, what we can do, we can rewrite the exponent as a whole exponent of that product. So this is called product to a power rule. Now in the reversed manner, we can also expand the powers. Let's say we have x times y and they already have a whole exponents. Say this is p. So instead of writing this as a whole exponent, we can still expand it. We can write x raised to the power of p times y raised to the power of p. So this rule is applicable on the previous questions that we are going to discuss. In that question, we have 4 multiplied to y squared and then we have a whole exponent. So what we can do, we can rewrite the exponent on both the terms which get multiplied here, which are 4 and y squared. Then we can simplify. This becomes 4 raised to the power of 3 and y squared raised to the power of 3. So 4/3 simply becomes 4 times 4 times 4. That's going to be 64. Whereas y raised to the power of 2 and again whole power of 3 get multiplied. That becomes y raised to the power of 6. So the answer is 64 y raised to the power of 6. Let's have a few more questions based on that product to a power rule. Here we have to expand these, so no problem, we can do the same thing. We can write the same exponent which is raised as a whole. We can write down this is 5 here as well as here, and there is a multiplication sign in the middle. We can just simplify, we need not to evaluate it. Here again there is no sign between x and y, so we can still imagine that to be multiplication, and we apply the same exponent. In this question we have 8 and x multiplied. They've got the 4 as whole exponent, so we can raise this exponent on both of them. So students, similarly we have a quotient to a power rule. Let's discuss that. Again, same idea, that suppose we have two terms in division and they have got the same power, say n. We can write it as a whole exponent, which is a over b raised to the whole power of n. And again in the reversed manner, if we already have some whole power on a quotient or on a division of two terms, say x over y raised to the power of m. So we can again separate them, x raised to the power of m over y raised to the power of m. Let's take a few examples based on that. We have to simplify, means we just need to expand it. We can just write the exponent separately here. Same thing we can do here, but terms already have some exponents and then there is a whole exponent. So we need to take care of some other rules that we may apply. So students, we can have whole power of 3 here, and here we can have whole power of 3 again. So students, again we have a power of power here, so we have to multiply them, and here also we multiply them. Now here multiple laws are applicable. We have product as well as quotient. We have 2 times c cubed over c raised to the power of 4, and now there is a whole power of 3. So that 3 is applicable on each and every component of this expression. So that's what we do here, and then after we have to simplify that. It becomes 8. Here it becomes c raised to the power of 9, and at the bottom it becomes c raised to the power of 12. And even if you further want to simplify this, you can still do that. You can apply the quotient law of exponent. You can subtract the powers, because right now we have got the same base right now here. You can see the same bases are there, and therefore we can consider exponents to be subtracted. That's going to be 9 minus 12. So finally we get 8 times c raised to the power of minus 3. That's your answer. Okay students, so 2 rules we discussed right now are product and quotient to a power. It means if we have 2 terms in product, we can have a whole exponent for example like this. We can expand, we can just rewrite the exponent as it is, that's okay. Even on division, let's say we have a over b and we have a whole exponent, we can still rewrite them separately, that's still okay. But students, for example, if you have got the 2 terms either added or subtracted, you have got the same whole exponent, let's say right now m. And now if you want to just do the same thing, students, we are not allowed to do so. We have different approach for that. That's called binomial expansion, that we'll discuss later. So this is not allowed, whereas this rule is applicable only on multiplication and division, not on addition and subtraction. So you have to take care of that. So let's continue with the next rule now. The next rule is going to be power of 0. That's very simple, students. Whenever you have a base and the exponent is 0, the answer is going to be 1. So it doesn't mean just only a, it could be anything. And if we have a power of 0, that simply becomes 1. So students, it could be say 2 raised to the power of 0, that's 1, x raised to the power of 0, that's 1, x, y, z, whatever. If it's raised to the power of 0, that's still 1. So students, in that manner, if you consider negative 3 raised to the power of 0, and that's of course equal to 1. But students, what about if I say negative 3 raised to the power of 0? Is it still equal to 1 only or something else? Students, as you notice that right now this negative hasn't got anything to do with this 0. In the previous example, we do have negative included within this 0, so that was equal to 1, there's no problem. But this time this negative sign hasn't got anything to do with this exponent, so keep this negative sign aside here, and your 3 raised to the power of 0 will still make it 1. So that's gonna be negative 1 this time. So this thing you need to take care of. If negative sign is kept outside of the parentheses, you have to keep it as it is. But if it's as a whole power of 0, that's still gonna be 1 only. Simple. After that, we have the next rule that is called negative indices. Now we can expand it further. So first of all, students, whenever we have a negative exponent, we can convert it as a positive exponent by just writing the reciprocal of the given exponential term. For example, you have 2 raised to the power of negative 5. So what you can do, we can rewrite 1 over 2, that's the reciprocal of the base, and then you can rewrite the positive exponent instead of writing the negative exponent. Okay, so just like here, you have x raised to the power of minus 2, you can write 1 over x raised to the power of positive 2. Here it could be 1 over 3 raised to the power of power 4. Over here, students, you have to notice the question is 2 times b raised to the power of negative 1 over 2. So right now this exponent hasn't got anything to do with this coefficient, so keep this coefficient out and then rewrite the reciprocal of b, which is 1 over b, and now the exponent becomes positive, so positive 1/2. This is how we can consider. To justify this rule, students, we can consider negative indices to be obtained when we have to divide terms in such a way that denominator's exponent is greater than that of the numerator's exponent. So in that situation, let's say we have x raised to the power of 3 divided by x raised to the power of 4. So as you notice that 3 x's will get cancelled and we'll be left with only 1 over x as these 3 x's get cancelled. But using law of exponent, students, we can further simplify this as subtraction of exponents, because that's the quotient law of exponent, and we again get x raised to the power of negative 1, which is obviously 1 over x raised to the power of positive 1. So that simply justifies our rule that negative indices can be solved in that way. Now again, students, sometimes we may have numerator other than 1. In that situation, the concept is still same. Let's say you have to evaluate 2 over 5 raised to the power of negative 2. So you can still follow the same rule. We can rewrite the exponent with a positive sign, and then we just have to write the reciprocal of the base. And if you further want to simplify that, you can still do that using any law. And yeah, that's how you can solve that. There's one more rule, students, that we can discuss for now. That's called fractional indices. Let's break it into 2 parts. First example, let's say we have an exponential term whose exponent is a fractional index, but it has a numerator of 1, say 1 over 2. So students, in that situation, we can use a radical symbol, which is square root of x. Right now we don't write 2 here because it's understood. But let's say we have some other exponent, that is 1 over 3. It can be written as third root of x or cube root of x. If it's 4, suppose it's going to be 1 over 4 we can rewrite it as fourth root of x. So in general, students say if we have x raised to the power of 1 over n, we can write it as nth root of x, means nth root of the base. And that symbol is known as the radical symbol. Now students, in the other case, we may have exponent as a fractional number whose numerator is other than 1. For example, it's 3 over 4. So now students, we can break it into two ways. Either we can write this as 3 times 1 over 4, or we can write it as 1 over 4 times 3. In both the situations, we get 3 over 4. Now students, as you have discussed rule of power of power law, where we have to multiply the exponents. So powers are already multiplied here. So what we can do, we can consider that to be a power of power. Same situation we can consider over here, which is 1 over 4 and then 3. So students, now we can notice that if you consider 1/4 outwards, as we discussed earlier, 1/4 is nothing but the fourth root of x, means fourth root of the base. So either we can write this expression like this, or alternatively we can keep 3 as it is, and we can say it's fourth root of x. So based on the situation, we can apply either of the rule. We'll discuss these rules in further questions. Let's try to recall all the rules with these collective questions, students. In the first question, we can apply the law of product law of exponents or multiplying indices. We can first of all keep the coefficients aside, and just because the bases are similar, so we have to add their exponents. That becomes 20. Just for making you understand, that doesn't matter in that scenario. The main task is to perform simplification. It doesn't matter of course, but just because we are learning laws of indices, so we are emphasizing on that. So the powers get added. 6 plus minus 2 becomes 4. Simple. Same thing here, we have algebraic exponents. Keep the coefficients aside, and then we have to add the exponents again because the bases are still similar. That's gonna be a raised to the power of 4 plus 7 is 11b. In the next question, we have to apply the quotient rule of exponent. 20 over 4 is just 5. Now the exponential term, we have to perform subtraction with their exponents. We get 5 times b raised to the power of 5. Let's look at this question. Again, we have to perform the same method. 42 over 6 is 7. Now a raised to the power of minus 3, and then we have got the same base, and we have to subtract the exponent. So as we simplify this, we get negative 3 plus 8, that's going to be positive 5. Students, as we discussed, 0 power, it's always 1, but we have 6 squared, so we need to simplify this. So that's going to be 36, or keep it as 6 squared only. Here we have the two terms, so we can consider it product to a power rule. We have got two terms with a whole exponent, so we can rewrite the exponent separately on both of them. Either we can leave it like this, or we can further use the reciprocal in order to look better. We get 1 over 5 raised to the power of 3 times 1 over x raised to the power of 3, or as usual, wherever there are many ways in which we can represent the answer. In that question again, 6 is kept as it is, b goes down as reciprocal, so exponent becomes positive. And the last question, we have a fractional exponent. So students, we have 64 raised to the power of 2/3. What we can do here, we can discuss it as 1 over 3 times 2. Now students, you know that 1/3 can be considered. First of all, let's rewrite 1/3 inside the parentheses, and then we have a whole squared. Now students, you know that 1/3 is nothing but the cube root. The cube root of 64 is 4, and now 4 squared is equal to 16. That's how we can simplify. So students, that's it in this laws of exponents. See you in the next lesson.